The final way that we have for combining functions is what is called the composition of two functions. The composition of two functions is written with this open circle, and it's read the composition of f with g of x. The composition of functions means to perform the function rule on this variable from right to left order. So it says to perform the function rule g of x, then you're going to get a number, and take that number and then perform the function rule for f. Another way to write this is as f of g of x, which is the exact same thing I said. First we perform the function rule g on x, that's going to give us a number, and then we're going to take that number and perform the function rule of f. One thing to pay attention is that the domain of the composition of f composed with g is all x in the domain of g such that g of x is in the domain of f. And we can see that if I actually kind of show this out, we're going to show it with this first example. So remember, a composition of functions takes a group of numbers, performs the function rule that's on the right-hand side. That's going to give me another number. And I'm going to take that number and I'm going to perform the function rule of f on it. So if we look at the domain of the composition is all x's in the domain of g. So this group of numbers is the domain of g, such that whatever I get by performing the function rule of g is actually in the domain of my f function. So let's look at this first one. Well, what's the domain of f? Well, the domain of f is all real numbers. The domain of g is whenever this is non-negative. So if I want to know when that's non-negative, I got 9 minus x squared is greater than or equal to 0 would be the domain. If I add x squared to both sides, I get 9 is greater than or equal to x squared. And then I want to take the plus or minus square root, so I get 3 is greater than or equal to x, or negative 3 is less than or equal to x. So if I want to combine these two, let's look at the number line. Well, it says that 3 is greater than or equal to x, so we can go that way. It says negative 3 is less than or equal to x, which is that way. So the domain for this function is negative 3 less than or equal to x, which is less than or equal to 3, or in interval notation, negative 3 to 3. So the domain for this function composition, we start out here where my domain is negative 3 to 3. Well, that's going to give me some numbers over here, which gives me the final answers. And we saw that the domain of f of x is all real numbers. Well, these are going to provide me with real numbers. So my overall domain for the entire composition is going to be from negative 3 to 3. You'll be able to tell as you start doing problems where we start having problems inside with the domains. What I actually want to do next is I actually want to perform this function composition, evaluate it at various numbers, so you can see how we compose functions. So for the first example, I want to find f of g evaluated at 2. Remember, composition of functions says perform the function rules consecutively from right to left order. So first thing I want to do is I want to find g of 2. And then once I get that answer, I'm going to do the function rule for f. There are two ways that you can show this on test or a homework. Well, the first thing you can do is you can write the number 2, and then you're going to write g of x over the top, and you're going to give me a number. Well, g of x says take 9 minus that number squared. Okay, so I'd actually get, the function rule would be the square root of 9 minus 2 squared, which is the square root of 9 minus 4, which is the square root of 5. Then I can perform the function rule for f on it. And the function rule for f says take this number, square it, and then subtract 9. So I take this number, square it, and subtract 9. Square root of 5 squared is 5. 5 minus 9 is negative 4, and that would be my answer. The alternative way of showing this work is using this definition, where you're just going to write f of g of 2. And what we're going to do now is we're going to evaluate g of 2. Well, g of 2, so I can rewrite this as f of, now write my g function, the square root of 9 minus 2 squared. Evaluate what's in the parentheses. 9 minus 4 is 5 underneath the square root. So now it says take f of the square root of 5. Now I'm going to replace that square root of 5 with my f function, which is the square root of 5 squared minus 9. Square root of 5 squared is 5. Minus 9 equals negative 4. So you can either show me a little arrow diagram as you're going from one function to the next, or you can show me that you're evaluating the inner function and then performing the outer function. Additionally, what you can do is you can write it as a single function. That's the composition, where we write down the inner function, and then we take the outer function on that inner function. So the way I would recommend writing it down is to write down the outer function, except everywhere there's an x, put parentheses. So I'm going to write down the outer function, and everywhere there's an x, I'm going to put parentheses. So that is my outer function. And then inside the parentheses, I am going to write the inner function. And now I have a single function that I can perform the function rule on. And this actually simplifies. The square root of 9 minus x squared, squared is 9 minus x squared. And then I have the minus 9. 9 minus 9 is 0. 0 minus x squared is negative x squared. And now let's see if we actually have the same answer. So if I'm evaluating this at 2, and we said that f of g of x is equal to negative x squared. Now let's evaluate it at 2. That gives me negative of 2 squared, which is equal to negative 4. And if we compare this answer to this answer, we see that we get the same thing. So just like with our arithmetic combinations, our composition of functions, we can actually compose the two functions and then perform the
mathematical operation on it. Or I can perform the mathematical operations and then compose the two functions.